This Amateur Radio Roundtable is brought to you in part by ICOM America. Okay, I'd like to say good afternoon, evening. Welcome to everybody out there watching Amateur Radio Roundtable. Today is Tuesday, October the 9th, I think. And you're watching Amateur Radio Roundtable on W5KUB. We also simulcast the show on international shortwave station WBCQ on 5130 kilohertz. And people in various countries are listening on shortwave and tuning us in tonight. If you're listening tonight, send us an email to tom@w5kub.com. Also, if you've got internet where you are, go to w5kub.com. And you can watch the show tonight and participate in it. You can see all the pictures and the videos and see our speakers. And you can also join in the chat room where you can ask questions and give us comments. We may open the phone lines up a little later where you can talk directly to our people here in the studio. Going to have a good show for you tonight. I think we got Riley back with us tonight. We're going to talk about something I didn't know, how to report, I think, a line interference to the FCC. You know, if it's really bugging you and it's a problem. I didn't know how to do it, but I was surprised. I think what the answer is. We got Martin FG with us, founder of MFJ Enterprises, and Martin is going to talk about some of the old radios he's collecting and maybe refurbishing some of them and things like that. And then we're going to move to a new segment called 50 megahertz and above with Pat Chowton, K7 LNP. And this segment is going to be based on VHF, UHF, SHF, microwave, Earth, Moon, Earth, meteor scatter, digital, all that kind of stuff that happens up in the higher frequencies. So looking forward to that. So, and I don't know what happened to Katie. I see Katie is not on tonight. She may not, she may be under the weather tonight. I'm not sure what's going on out there, but it's not a problem. We have plenty to show you tonight, and everything's new tonight. Hey, you had a great net on 40 meters tonight. We had about 25 or 30 check-ins, pretty good signals out there. And if you're new, and if you just found out about the show, maybe by checking in our net today, tell us in the chat room. Give us your call or your name and say, hey, I'm new here. And maybe you saw it on one of the Google postings I posted or Facebook or something like that. So we'd love to hear from you if you're new. Let us know, how you found us and glad to have you there. So let me just go around the table real quick and say hello to our other co-hosts tonight. And we're going to, and then we'll get started here in a minute. So let's see if I can do this. So I'm going to go first to Riley. Just say hello to Riley. How you doing, Riley?
Hey, Tom, Martin, and everybody. Doing fine.
So how's the weather up there in Pennsylvania, man? You got any hurricane stuff happening or anything?
No, it's nice right now. We had a cold spring and an extremely rainy summer, but it's nice right now. I don't think we're going to get much, maybe a little bit of rain from the hurricane, but
yeah,
it's hard to tell right now. But the weather's nice right now.
Well, I talked to several people on the net today. They're going to be right in the middle of the line of it down in the Panhandle. And Kathy and I are going to our home in North Carolina Thursday. It's about a 500-mile drive for us. And as we get there in North Carolina, the remnants of the hurricane is going to get there at the same time. So I think we're going to be driving through 3 to 5 inches of rain probably Thursday.
What part of North Carolina are you going to?
It's in western North Carolina. We have a home in the Smokies near, well, let me give you the best way I can describe it. We're about an hour southwest of Asheville.
Okay, I know where that is.
If I told you we were in Tuckasegee, would you know where that is? No, you probably.
Tuxedo. I know where Tuxedo, North Carolina is.
Yeah, well, we're in Tuckasegee, and in fact, we have someone in the chat room tonight from Tuckasegee, a friend of mine, Jeff over there. And if I told you the next bigger city that we have to go up to is called Cullowhee, you may have not heard of that, but
I have.
That's where the Western North Carolina University is.
It's also where they had a beauty pageant last year and nobody won.
Is that right? Nobody? Oh boy.
Second, third place.
I'll have to ask Jeff about that when I get over there this week. And then, hey, then the next bigger town, if you go third town north, man, that's where we have our Walmart and our Lowe's, and that's called Silva, North Carolina. Now, we do have a little store just opened up in Tuckasegee there, dollar store or something. Boy, they got everything. They got bread and milk and Band-Aids and light bulbs, so we don't have to go out of town anymore.
Well, I know where Silva is. I'm familiar with those
Okay.
there.
We're just 15 minutes probably south of Silva there. All right, let me jump over here and let's pick Martin up. Martin, how you doing tonight, Martin?
Oh, I'm doing really good. This weekend, while you're traveling to your second home, I'm going to Jackson, Mississippi for a 56-year high school reunion. The school that I went to was a public high school in Hollandale, Mississippi, that closed up in 1970. So this reunion is for everybody before 1970, and I graduated in 72. And the last one I went to, which was like 2 years ago, there was someone from the class of 1949. So our reunion class is slowing down or getting smaller. And after that, I'm going to drive to Birmingham and to Atlanta during the same time period that you're traveling to. I forgot where you said, South Carolina?
Yeah, North Carolina. North Carolina, yeah.
North Carolina, okay.
Mhm.
Anyway, I'm driving around the same path that you're going to be driving.
Well, cool. Well, hey, Martin, my high school does the same thing. Our classes were so small that they just have a reunion for everybody from like 1940 up, So.
The internet path is really bad tonight.
Oh, is it? Yeah.
Catching just 2 syllables here and there.
Okay, well, maybe it will get better. Let's jump over and see what Pat's doing out in Salt Lake City. Hey, Pat, how you doing?
Good evening, Tom and the group and everybody in the chat. How are you tonight?
Well, we're doing pretty good, man. Now, you're going to be talking about all that good stuff I just mentioned, right? It's about time we talk about VHF and above.
Oh, for sure, we will. It's going to be a long winter, so plenty of projects that people can work on, and it's a great time to have fun on those bands.
Yeah, okay. Power line interference or something to the FCC?
Yes, I wanted to talk about RF interference and the FCC. And I'll keep it short. The thing to remember is you don't immediately go to the FCC when you suspect that you have power line interference. Now, I won't go in, or any kind of interference, I won't go into how you detect it because there's lots of publications and guides on that on the league website. What I want to talk about is RF interference and the FCC complaint process. For about 20 years now, the FCC's worked with the American Radio Relay League Lab in a cooperative agreement whereby the staff of the lab takes the first cut at resolving your radio frequency interference case. Now, the lab will work with you to make sure that the noise is narrowed down to the most probable source. And the thing about it is the success rate with the lab working on these cases is right around 80%. It's always been very high. And in many cases, the complainant saw the problem without any FCC involvement at all. The lab can help you with the proper testing that you need to do and with the documentation you need in the event that the matter is referred to the FCC or the power company. I was always amazed at the number of situations in which the noise that at first seemed to be absolute power line related was in fact, and here's some real examples, a nearby electric fence, they're notorious, a battery charger for a golf cart, or an Ethernet adapter, even a paper shredder, and even a circuit board and a brand new clothes washer in a room adjacent to a Radio Shack. These are all real examples. You can't assume anything. Of course, the first thing you do is shut off the power in your house and put your transceiver in battery operation and make sure nothing else in the house is operating on battery. And if you still hear it, then it's not in your house. It's not originating from your house. If you don't hear it, then go back breaker by breaker and turn everything back on until you hear it. And that's a good way to basically isolate it if you have a fairly simple. But you have to, you can't assume anything. You have to test every possibility and document your testing. And not only will you learn a lot about the devices in your house and what causes noise and what doesn't, but good documentation will make your case easier and stronger if you do have to go to the FCC. So you have to follow to the letter the legal articles and website tutorials in tracking down noise in and around your house. And on the league website, you can even hear noise samples, different types of radio frequency interference, and that's very helpful. The documentation is important. It does turn out to be power line related, and you have to start dealing with the power company. So you need to take notes of every call you make, who you talk to, and when. And this helps not only the power company, but also the FCC, and in the unfortunate event that FCC action is required. Now, in many cases, the power company staff has a lot of experience running down noise interference cases, and they take a lot of pride in locating it. In other cases, the power company's been bought and sold or merged or whatever, and doesn't have the staff with a lot of experience in these matters, and sometimes the staff will have no experience whatsoever. So a lot of it depends on the particular power company that you're dealing with. Now, power companies need to understand that the cost of the equipment required to track down power line noise is less than that of 2 employees in a bucket truck for a day. Often we hear the power company squawking that they've spent $40,000 trying to track down the interference. That tells us right off the bat that they don't know how to find it. And that opens a whole host of other problems. Sometimes a consultant has to be called in. Sometimes the power company will be required to do it. But often the source of power line noise is a simple piece of equipment that's loose or about to fail. So finding the source helps the power company maintain its system. And you have to keep in mind, though, that in some areas, they are just not suitable for amateur radio. If you happen to live next to an old substation or a conglomeration of old poles and transformers or an industrial area, your situation is very tenuous because, you know, whether it's our roads or power grids, a lot of the infrastructure in this country is plain old, out of date. So you have to test diligently and document thoroughly, and never go to the FCC with a situation when you have not already worked with the ARRL and the power company, and particularly the ARRL staff and the technical department. That's how to get the complaint going. And in most cases, it won't have to go to the FCC. But in the ones where it has to go to the FCC, if you have this documentation and you can show that you worked with the league, it's very, very helpful. And in most cases, if the league has worked with you to narrow it down, the league will be doing the referral of the case to the FCC. That's the good thing about this. So, Tom, if you want to have another session on how to find it, we could do that. But there are so many articles on that, I'm not sure that that your listeners need that. But whatever you would like to do is fine with me.
Okay.
But, for those of you that suspect that you're having an RFI problem, call the league and ask for the technical department. And they're very, very good. I've seen them track down interference many times, and they are excellent at it. Sometimes they can listen to it on your telephone and narrow it down, or at least tell you what it is not. And that's very helpful.
Well, some people in the chat room were talking about how their power company worked really well with them and helped them find it. And of course, like you mentioned, some just may not be very helpful. Riley, I noticed something new here the other day, and I wasn't sure what it was, but I saw some new noise on my scope, my Spectrum scope. About every 50 kilohertz, I saw a carrier. Every 50 kilohertz, all the way from 80 meters to 10 meters. Boy, it was in there. And I didn't really have any idea what it was. And then I started doing some reading about some interference, and someone identified that the smart meters that they were using put out a spurious emission or something every 47 kilohertz. So it got me thinking that that's probably what I've had going on here. They put a new smart meter on me this year. Now, I don't see it every day. I only saw it that one time.
There's a lot of that stuff out there, and there's a lot of RF junk, too, that it's hopeless for the FCC to keep up with. So this is going to be a constant battle for us, and we'll have to be diligent.
All right. Well, that's great to find out. I mean, a lot of people I've seen in Facebook, when they start talking about interference, they say, call the FCC, send a letter to the FCC. But we can see right now that's the wrong place to start.
Yes, it is, and go through the basics, the basic tutorials on how to isolate. Then go to the league and work with the league from there on. And if it seems to be a case that will go to the FCC, they will help you with that. And it'll go a lot simpler, a lot quicker, although a lot of these cases are not fast, but it just gets better if you do that, because that procedure, the FCC's worked on that procedure with the league, as I said in the beginning, for about 20 years now. And the reason they do that is most of the cases are pinpointed through working with the league, so that you know what it is before you even go to the FCC. And if it's a neighbor or something, the league sometimes will write a letter for you to that neighbor. It helps if you don't get in a fight with a neighbor that you suspect is causing the interference, because at that point, no letter from the league is going to help if you've already made enemies of your neighbor. So you have to be very diplomatic if you're convinced that it's coming from a neighbor's house.
All right. Well, maybe next time we have you on, we can go a little deeper into some other aspects of this.
Okay.
Hey, well, I've got you and Martin and Pat on. I want to show you a picture here or something. I thought I knew a lot about antennas over all the years, but I must not know much about them. WBCQ is building a new station. I guess they've got some money, and they're building a new station up in Monticello, Maine, and they claim it's going to be one of the most powerful stations in the world, and most modern in the world. This is the construction of their antenna. Look at this thing. Here's another shot of it, and here's a shot here. I have no idea how that's an antenna. It'd be neat to kind of understand what all those pieces are, but
It'd be even neater to have it.
yeah, wouldn't it though? It kind of looks like a power station or something, but that's the antenna, and this is a company, I think out of the Netherlands or somewhere, that's putting this in. This is supposed to be one of the top shortwave antennas in the world, man.
Nice.
I bet that costs some money.
Looks like it's even it can be rotated.
Yeah, I don't know. I'm wondering if you can rotate that. I have no idea. But man, it's it's there. Martin, you ever seen an antenna like that, Martin?
I don't think so. I toured a huge shortwave broadcasting transmitter in Birmingham,
Yeah.
and they had a wire array. Nothing like this, though.
Yeah, most of those places use rhombics and things like that, where wires are like miles long. But I don't understand how this is going to work, but it'd be cool. I'm going to have I'll get Alan Weiner on our show here in 1 week and let him talk about this. Alan is an engineer, and he's been in all the surplus equipment and military stuff. That's how he put the shortwave station on, basically. And he never got his ham license, but he is a RF engineer. We'll get him on here and we'll ask about this.
I'd love to see the National Park Service's reaction to the proposal to put that up next to the Gettysburg Military Park.
Yeah, well, boy, that'd be something, wouldn't it? Well, look, while we're talking about antennas, and then we're going to get off that subject, I've got one more little clip here I want to show you. I'm not sure where this was. It was on Facebook, but these guys are raising an antenna. It looks like about 180 feet, I'm guessing, but they're setting it up with a crane instead of starting at the bottom and going up. Why don't you look at this? Let's see if we can.
Where is this, Tom?
I'm not sure where this is, but I want you to look at this. Oh, let me run that back again. I didn't have the picture adjusted very well, but let me start this over. That's a pretty tall piece of tower.
It sure is.
I mean, if you look at the people standing on the ground at the base, I don't know how they thought they're going to bolt that to the ground once they stood that thing up. But look at how tall that sucker is. Oh, wait a minute. I've got to click this. This will make you guys see it better. One more time. Here we go. One more time. This is just very interesting to me that they tried it like this, and it was not. It didn't work. Here we go. I guess the weight above that top half was just so heavy. The tower bolts and legs couldn't hold it. Look at that. Well, they were trying. I'm sure they were trying to save some time because they already had the antennas mounted on there, and it looked like,
I know a lot about towers, but I think I could have told them that probably wouldn't work.
Yeah. Tower, tower worked on.
Sailboat mast collapse the same way. You just don't do it in the middle.
Yeah. All right, Riley, stick around if you want to. Hey, we're going to talk about some old vintage stuff. Martin's going to talk about old vintage stuff, and if he gets boring, you can take over, okay? Martin, you ready?
Hey, Tom.
Are you ready, Martin?
Can you hear me?
I hear you.
Okay, I can't hardly stand watching somebody climb a tower. I mean, it's just terrifying to me.
Well, Martin, you probably didn't hear the news. I announced last week on the show. I have a friend that retired with me from FedEx, and he's building his retirement home in Cookeville, Tennessee, and majorly big ham shack. He's been on our show before. He's been here as a guest, and they were putting up a tower, probably a second tower, and they were up at 80 feet. And he had a guy helping him put it up, and the guy was at 80 feet, and one of the guys broke, and it killed him last week.
Man.
This is a ham friend of mine. So. Prayers and thoughts go out to the family for the death of the climber. He was 30 years old. He'd been climbing towers 12 years. I guess that means he started at age 18. And he leaves a family of 5 kids, 2 sets of twins, and it's tough. And I know Skip's having a hard time dealing with it, to have something like it happen,
Well, Tom, is he putting the antenna on it?
No, they were just at 80 feet and a guy wire snapped. They were going up with the tower. I don't think the guy wire actually snapped. I think it was a bolt that maybe went through one of the turnbuckles, where it holds it on. I think that's what it was. I don't have all the detail yet. All right, well, Martin, let's talk about some old radios. That's one of my favorite things to talk about here. And I've got pictures, Martin. So where are we going to start, Martin? Now, you've got so many. You've collected so many radios, and we've shown those on our show before. But you picked out 3 or 4 different radios here we're going to talk about tonight. Is this something recent that you're working on?
Yeah, this past weekend I worked on all of these, and I just got an itch for it. When we first made our first contact as a novice, CW back then, crystal control, less than 75 watts input power, and I didn't know very many hams that could have 75 watts input power. But our first contact was always a thrill. And I've been a ham since 1962, 50 6 years ago. And from our first contact, uh, we have been searching, at least I have been searching for that same thrill that we had during that first contact. Well, back then there weren't very many radios that you could buy. And, I wanted some of them. As a kid, I just didn't have the money to buy it. So I have been collecting these low end novice grade radios, and my office full of them. And last weekend, I had this itch to play around with them and get some of those things working. And I've taken some pictures, and I just wanted to talk about a few of
So
those.
let's start with one. Which one you want to start with?
I don't know which one you got up first.
Oh, I don't know. Any of them. Let's talk about this. Let's talk about this is a Heath kit, I think, AR3.
Oh yeah, that was like a very early one, like 1955, 1958,
I
something
got
like
one of those
that.
downstairs.
Yeah. Look at the
Oh
dial on that
really?
thing, man. When you dial somebody in, you're lucky if you're within 50 kcs of him, aren't you?
Well, there was if you look on the lower right hand corner, and Riley would know that, there is a band spread
Yeah.
tuning knob there. It's a vernier capacitor, but it wasn't that vernier. But you could, if you touched the knob just right, you could get a CW signal in.
Yeah.
But, like the Helicrafter S38 was a 5 tube AC DC radio, All American 5. Well, this AR3, it was a Heath kit, and it was a kit, had 6 tubes. One of the tubes was a BFO, and the other ones, they were competitors, had a BFO, but what they did was to make the IF stage oscillate. But this one had a real BFO in it. 6 tubes, and the other big difference that this radio had was it had a AC transformer, whereas the S38, which was probably the most popular one back then, was AC DC. And if you didn't plug that thing in right, you could touch it, and you
Oh,
would
yeah.
be surprised with the shock of your life. That looks like the inside of it. You see that power transformer, and it had a speaker built into it. But
Yeah.
it was pretty neat radio. It wasn't all that mechanically stable. What do you think about that, Riley? Did you operate that as a novice?
I didn't. I had that one to listen to shortwave stations and ham stations, and I got that after I had got that night kit space spanner. But somebody gave me one of those about 5 or 6 years ago, and I have one. That's it. I have downstairs. It's not the one I had as a kid, but man, I wonder how
Okay.
many of those were made.
I think there were
They,
a lot of those
they,
made. There was an AR2 also, just
Yeah.
before this one. You said you had a space spanner night kit?
I built one when I was a kid, and I still have. I refurbished it several years ago. And although the shortwave bands aren't what they used to be, with so much internet and little country, some of these little countries, it doesn't pay to build a huge 100,000 watt station when they can just rent time on an American shortwave station. So you don't hear the same things in the shortwave bands anymore. But the first shortwave receiver I had was a night kit space spanner. It was 1995 from Allied Radio. I've still got it sitting right over here
Right,
at the rig right now.
Riley? That was the first radio I had. I had was a night kit space spanner,
Yeah.
and I have my original space spanner, and I modified it, put a hole in the chassis where I could put plug-in coils from the ocean hopper.
Okay. I remember
Well, it
the.
didn't. Yeah, it didn't work, so I had to fix it back up like it was. It's upside down now in my office.
Yeah.
When you come back to see me, I'm going to show that to you.
You learn by doing and then learn by fixing what you did. That's what it amounts to.
You
Yeah.
know,
Great.
yeah, and and Martin, back in the '60s, Martin, we didn't have a lot of the newer things, but later they came out. What was it? The Twins? What was that like? Some company, what
Talking
was
about
it?
the Helicrafters.
Well, no, what was the other Twins that came out? I mean, a little bit later model. It may even have sideband in them, but I can't think of the name now. But anyway,
Canar, he,
yeah, back
go
back
ahead.
go. Hey, this was a twin. Here's a twin back when we were in. That was a twin right there.
Uh,
Oh, yeah. I've worked on one of those this weekend too. On the left side is the receiver. It's a super hat, but that was ham band only. 80 meters, 40 meters, and 15 meters. It looked kind of crude, but it was really one of the better receivers.
Is that right?
It had a halfway rectifier, so there was some hum in it, but it worked pretty good. Better than like S38 and better than the AR3 for ham operation. It didn't have a product detector, so you had to ride the, I don't know if they had, I can't remember if it had an RF gain control, but back then, if it didn't have a product detector, what you did, because the BFO injection wasn't high enough, wasn't enough. So what you had to do was to turn the volume control all the way up and then use the RF gain control for volume control because the BFO injection wasn't enough. If you did that, then it worked fine on CW and on sideband. But that
Now,
was a nice little radio. That was part of the National Radio Institute course on ham radio.
yeah, I was going to
And the
say
other,
I didn't. You couldn't just buy this radio on the market, right? You had to take their course, and they would give this radio to you to build with their electronic course.
that and the transmitter.
Yeah. So in the transmitter, it is a twin. It's a matching. Let's see if I can get the right mouse here. So I'm gonna go back to the transmitter. There it is, right there. Got a crystal in it and everything. So looks like it's got the
See that?
Pi network there.
See that? You see that meter on there?
Oh yeah.
Do y'all remember the moving magnet meters?
Oh yeah.
You know,
It used to really bounce
it
around,
was
didn't it?
oh yeah, it would just bounce around. You couldn't
Yeah.
hardly tune it. That was
Yeah.
that was different from the DeArvison meters. Do you remember that, Riley? Those kind of meters?
no, I don't.
Yeah. The movement in there
Okay.
was just
Yeah.
crazy. It just swung like crazy back and forth. It like it had no damping or whatever. The new
That
meters
might
have.
be the kind
Yeah.
of meter that was on the Johnson Challenger. It seemed to knock all around the
Yeah.
meter keys.
Probably
I
the
shut
same.
up, just disconnect the meter when I was transmitting because I thought it was going to tear itself up.
So, Martin, now, here's another one I've got here. This is one of the heat kit VFOs.
That's a HG10.
Uh-huh.
There was a HG10 and a B model, and the only difference was the cabinet on the B model was a crinkle finish. But if you see that dial there,
Yeah.
if you turn the band switch, that dial is a drum and it would rotate to the next band.
Yeah, and how you like
And
that? How you like that readout, man? Look at here, 27.0, 29. Boy.
I have one of those downstairs that I use with the Drake 2NT CW
Oh
transmitter,
man,
and it
man.
was well with that.
All right.
Now
So
that's
you're working
that's a
on
good,
you're working on one of these, right? This is the HG10.
yeah. Well, I bought one of those off of eBay
Uh-huh.
and got it at a good price, and I found out why. The function switch, some guy had glued back together, but the function switch didn't work,
Oh.
and
Yeah.
it was a three position, and I studied the schematic, and they only used two of the pose, so I had
Uh-huh.
a 6 position 2-post switch that I substituted for it and got it to
Good.
working. It's got, if you look at it, you can see a whole series of gears on the left side.
Yeah.
And I got everything to work, and it's working real nicely now. But I didn't hook it up to a transmitter. Uh, but what I found out was there's lots of backlash in it. You know, you could turn the dial,
Mm-hmm.
and nothing would happen until you turn it a little bit, and then when you turn it back, it wouldn't change frequency until you moved it. So there's an anti-backlash mechanism on one of the gears that I need to go back in there and fix. But
Well,
that one,
isn't that on the gear in the middle? Weren't there little springs down on the side of that gear? That big
well,
middle? It might be that.
well, well, I'm glad you're telling me that because I never noticed it. I will look for that spring.
Well, you see
And
Mm-hmm.
that in the middle, that's actually two gears,
okay,
two gear plates, I think, if I remember correctly. Check there first.
Mm-hmm.
okay, I will check there because it's really annoying to try
Yeah.
to tune and yeah. But you know, the one before that was the VF1, which was a much simpler one. And but the HG10 had a cathode follower
V,
after the oscillator, and the VF1 did not.
there's a
Uh,
VF1 right there. Let's see. There's a VF1 right there.
Yeah, I remember that.
oh yeah, yeah,
Isn't that
yeah.
that fancy green display there? That's cool.
I
And
had
you
one of
see,
those with.
Tom, even in those days, it had one big knob.
It did. It did. It had one big knob there. Yep. And there's hey, there's a shot inside the VF1.
You know what the VF1 used for a vernier? It had a little clutch, a little thing that, well, okay, that green screen that you see is a big
Uh huh.
round plastic dial, and on the edge of it was a little thing that rubbed, that
Rub the big one. Little wheel turned the big
squeeze.
wheel.
Yeah, it rubbed the big nut,
Uh
the
huh.
big dial, and that's what they used for a vernier. I mean, it worked pretty good.
Yeah.
I have
Yeah.
I have several of those. I'm going to transistorize it. One of those. I'm just fooling around. I'm just trying to relive my novice days.
Yeah. All right. Let's see. We were talking about the HG10 a minute ago. That's the HG10 VFO, and that's the inside there, and we talked about that a little. Looks like there's a voltage regulator tube, and what's that other big, the tall tube? Is that the rectifier, or I don't know
Well,
what that
let's
is?
see.
I,
It had a one tube that was a dual tube, which was the oscillator.
I think that's one on the
It
left
was
there.
like an electron
Yeah,
couple oscillator. Then the
yeah,
cathode follower. The other tube was a OB2 voltage regulator
yeah,
tube,
yeah.
about 105 volts or
I was gonna
so.
say a OA2 or OB2, something like that, if I remember correctly. But that's one of the tall
Yeah,
ones there. Yeah.
yeah, that was a, I think that was a OB2.
Uh huh.
The
Probably
original
was.
VF1 was a OA2, which was much higher voltage.
Now here is another one you're working on. This is the HR10.
The HR10 during its era was one of the better ham radio receiver. That was a ham radio, I mean, the ham band only receiver. Had RF stage. It had a crystal filter, half lattice crystal filter, and the IF around 1700 kilohertz, two IF stages. Did not have a product detector, but it was pretty stable and worked really good on 80, 40, and 20. On 15 and 10, it used the second harmonic of the local oscillator, so it wasn't very sensitive there. But that was one of the better receivers during that era. It was better than the Helicrafter, what was that called? The SX140,
I have
better than
140.
the
Yeah.
AR3 and the R55, R100. most of those had 455 kilohertz IFs, and you could hear images on it. But this one had a high IF, and the images were not nearly as bad of a problem. And it was $79.95 as a kit that you put together.
What did
And
you?
I have.
Yeah. What do you think
Mhm,
about? What do you think about the? How was it on drifting? Did you have to let this one warm up very long?
Well, all these old tube radios, you had to let them warm up for 30 minutes to a half an hour. But the one I had was pretty stable. You could listen to sideband on it and leave it on there, and it would stay put for a pretty good while.
Uh huh.
30, 40 minutes, and you might have to retune it. But
Yeah.
this was back in the 50s when everything drifted.
Oh yeah.
If it
Yeah.
didn't drift, it wasn't ham radio.
Well, here's the inside of an HR10. It's got a nice power transformer on it there. And I see, looks like the crystal 100 kc crystal oscillator over there. You might tell people what the crystal oscillator was for.
Okay, you talking about those two crystals in the middle? I don't see
No, the one
part of
over
the
on the
picture.
left. Can you not see the left?
Okay. No, I can't see that, but
Okay,
I know what
here's
you're
what it looks
talking
like. It
about.
looks like this right here.
It
That's
was,
It looks like
crystal
this.
caliber.
okay, yeah. Yeah, that was optional. It's a 100 kilohertz oscillator, and there was a knob that you turned to zero beat at every 100 kilohertz. So, because the dial wasn't very accurate, and you had to stay within the ham bands.
Well, that's
But
kind of
that
like
was,
my electric meter, right? It puts out every 50 kilohertz. This thing used to put out every 100 kilohertz. Yeah,
yeah.
yeah.
If you try to buy the crystal calibrator, it costs almost as much as the receiver now.
Is that right? Well, I saw. I'll send you one. I was looking through a junk box out in my building last week. I found a crystal calibrator just like that out there. If you need one, I'll send it to you.
Hey, Tom, I'm going to hold you to that. I need one
Okay.
of those.
Okay. All right. We'll get there. Look,
But
that's
you see
pretty.
those two crystals in the
Let's see.
middle of it?
Uh,
Go
yeah.
back to the last picture. You see that crystal right in the middle behind the
Yeah.
tuning
Yeah.
capacitor?
Mm-hmm.
There's two little crystals between the IF transformer and the tube toward the back behind that tuning capacitor. It looks like it looks like two little cans that's standing up. Anyway, that's the half lattice crystal filter. It's like a 3 kilohertz crystal filter.
Mm-hmm.
That was pretty amazing back then because very few receivers had a half lattice crystal filter. I mean, some of the old Hellcraft they had one crystal and a phasing knob on it.
Uh huh. Well,
Is that the bottom of
that's
it?
the bottom. It's pretty simple. Not a lot under there.
Or can you imagine putting that thing together, resistor by resistor
Oh yeah.
and capacitor by capacitor,
Well, it was a
point
lot
to
of
point
fun.
wiring back then?
I remember getting those kits, and I'd open it up and I'd lay all the parts on the bed and spread them out. And I said, my goodness, look at all these parts. But you know what? Every one of them went in there. You just follow the instructions, and their instructions were really, really good.
Those were great days back then.
Uh huh. There's a picture of the back right there. I'm not sure what the octal plug is there. Multi-muting. It says muting. I guess that's for
I
muting your
forgot.
receiver if you used it with a transmitter.
Yeah. Well, back then, most receivers had 455 kilohertz IF, and some of the Heath kits had octo plugs like that where you could plug in a Q multiplier,
Mm-hmm.
and that would increase selectivity greatly. The
Yeah.
AR3 had a place where you could plug in a Q multiplier, and it made it work really nicely. It was like band pass tuning through the IF stage,
Uh-huh.
and you could pick out one CW signal and peak up on it. But if you increase the Q on it, it would go into oscillation. And anyway, it was a really good addition.
Mm-hmm.
Back then, QF1Q multiplier was $9.95. But if you bought it nowadays, it would be like $50 to $75.
Oh, wow. Now, here's a very popular radio here. This is a 16, HW16.
That was a great radio. It was built for the novice, 80 meters, 40 meters, and 15 meters. It wasn't a transceiver. It was a transmitter and a receiver. The receiver had a 500 hertz half lattice crystal in it, and on all three bands, the tuning had the same rate. It was basically a converter that converted to a receiver that tuned from it tuned 250 kilohertz of it. Very stable. It had a 3-tube transmitter in it. You could operate it with a crystal, or you could plug in the HG10 VFO that was designed for it. And the input power, I forgot, I think it was like 75 watts or 90 watts input. Output powers was 40, 45, 50 watts.
So instead of a
Had
crystal,
RF gain control.
instead of the crystal, you would just plug this VFO in there and run VFO.
Yeah, the way you operated back then was you would tune in the signal that you wanted to make a QSO with, and then you would take your VFO and zero beat it, and then you would call them back.
Yep.
Back then, most novices were crystal controlled, so you would call CQ or you would listen for a CQ. Let's say you call CQ, and you want crystal control, and then you would have to tune around your frequency and see if there was anybody that was listening to you. But with a VFO, you could listen, hear the guy you wanted to talk to, and then zero beat them with the VFO. That HW16 had a side tone built in, had a TR switch. I mean, it was pretty neat, pretty advanced radio.
Yeah. There's the inside there.
But
Say
that again.
State of the art at the time. Those things are sought after today.
Oh, yeah.
Oh, you got to pay a lot of money for those now.
Yeah.
But,
Well, look there's what it looked like in the bottom.
Yeah, look at that. It's got a PC board in it.
Yeah.
You didn't have to do all the wiring point by point.
But you can look at that and you can tell it's a pretty crude PC board. You could tell you could date this looking at that board, but still, it had a board. You didn't have to wire all those wires, man. You got a PC board.
That's right. And look at the PC board. It's brown.
Uh-huh.
That was phenolic material, unlike the PC boards that we use now, which is made of fiberglass.
Right. Oh.
That was a great radio. I must have 6 or 7 of those.
Right.
Yeah.
I'm converting one now, the 15 meter band to 20 meters, and I have to have a custom-made crystal at 19.545 megahertz. And I found a place in England that would make me a custom crystal. And I'm going to take another one of those and make the 15 meter band 30 meters. And that takes a 15.454 megahertz. But I've been listening to 20 meters by injecting and signal at 19.545 megahertz from a MFJ 259 SWR analyzer. And I can listen to the 20 meter signal just by injecting that into it. But anyway, I'm waiting for my crystals to come in.
All right. Here's another one. Boy, this is a beauty.
That is a Night Kit R55,
Uh-huh.
which was a takeoff on the Helicrafter S53 and the S107 in that it had two IF stages. Now, one of the differences is that it had AC transformer in it, but it also had a high IF. It had a IF of 1700 kilohertz or 1682 kilohertz right above the broadcast band. And so the image rejection was much better.
Mm-hmm.
um, uh, let's see.
There's a shot there of the power transformer and probably the tuning capacitors. And did it have a band spread on it? That's probably, yeah, a band spread capacitor there.
It did have a band spread. This
Yeah.
one had a kind of an unusual problem with it. It mixer uh, the mixer wasn't working, and it took me a while to find it. It was the tube socket. Tube socket
Ah.
wasn't making good contact on one of the pins, so I replaced the tube socket, and it works pretty good. Um, the when I got it, the 6X4, that was the power supply rectifier, was broken, and I didn't have a 6X4, so I replaced it with two silicon diode, one N4007,
Mm-hmm.
and replaced the filter capacitor, and it works good. Mechanically, it's not very stable. You know, you can
Uh-huh.
tap on it and the frequency would change, and it was microphonic. You could tap on the
Oh
tubes
yeah.
and the frequency would change.
Oh yeah.
But
Yeah.
those were the kind of things that we had to deal with back then. But, you know, back then everybody was unstable.
And even look at the tubes. People might not know what these are, but they're actually metal shields that are around the tubes.
Yeah, that was kind of interesting. You can see some tubes by themselves and some tubes with the metal shield on it.
Mm-hmm.
Uh, in fact, in this picture, there are two different kind of metal shields on
Right.
it.
Now the equipment's very stable, but a lot of the operators not so much.
Yeah. Yeah. So, Martin, here's something here. Now, this doesn't look like anything here that we would have bought or collected here. What is this you're working on?
Oh, I just played with that thing today. That tube there is a 5763, and I don't know, 2, 3, 4, 5 years ago, I bought 100 of those, and I was going to do something with it, and uh, did something with it 2 or 3 years ago. That's a PC board. I put a hole in there for those three 9-pin tube sockets and just glued them in there.
Uh-huh.
But this is a single tube uh, crystal controlled transmitter, and I used a power supply that was just a transformer, 120 volts in AC, 120 volts out AC, and voltage doubled it, and has 6.3 volts for the filament. And if you see that black thing right in the middle, that's the crystal at 7.040
Oh,
megahertz
yeah, I see it. Yeah.
in the CW band. It's a FT243 crystal, old World War II crystal.
Yep.
And at that low voltage, I got about 4.5 watts on it. If you look on the bottom left, there's two capacitors, and right above it, the red coil, that's toroids. That's the Pi network on the output. Now I can get 4.5 watts, and I had to leave and come home or have some other meetings. I didn't get a chance yet to work anybody, but I'm going to. And the other two tube sockets that you see there, I'm going to build maybe a one tube or maybe a two tube regenerative receiver on it. And what I really like to do is to take a one tube, like a dual trial, and make a regenerative receiver and make some contacts. And I know Raleigh done like for me to say a one-tube regenerative receiver because it doesn't have an RF stage and it'll radiate back and put signals onto the ham bands that shouldn't be there.
Wow, man. Well,
Hey,
hey,
that was like the space banner, Riley.
Yeah,
That did the same thing.
yeah, sure.
it's been fun looking at all these old ones. They bring back a lot of memories, but I think Martin's buying all of them up. I don't have any of those. I don't have any of the old stuff I started off with, but at least I can go down to Martin's and look at them. You know.
Hey, I got so many of them. You tell me which one you want, you can have one of them.
All right, well, I might have to come down here. But you've got my novice rigs. I mean, you've got my T150 and you got my SX140. You've got all those down here, man. Oh, those are some days. Well, Martin, hey, that's been kind of cool talking about those tonight. Very interesting. We'll need to do some different ones another time.
Okay. Yeah, I
Tom,
think we got something.
It's 10 o'clock here. I'm going to go ahead and sign out with you if you don't mind.
Okay, all right, Riley. Well, thank you, Riley, for coming in tonight and talking to us, and we'll see you on the show again here in a week or two, whenever you have time.
Good to see you guys. Enjoy them.
Take care,
All
Riley.
right,
Yeah,
73.
good seeing you, Riley. We'll
Talk
see
to you
you
later.
later.
73.
All right. All right. Well, all right. Hey, that was a good segment there. Everybody, stand by a second. We'll be right back with you. We're going to talk about 50 megahertz and above in just a minute. It's time to get the transceiver that's best suited for your lifestyle. ICOM offers a variety of high-performance and innovative products. See how you can make the most out of contest season with one of these transceivers. The competitive edge you've been looking for is in the IC7851. Raise the bar and hear what others cannot hear with this flagship HF 50 MHz transceiver. It has reciprocal mixing dynamic range, crystal clear local oscillator, spectrum scope, dual receivers, and a digital voice recorder. The IC7610 is the SDR every ham wants, and just in time for contesting season. This high-performance SDR has the ability to pick out the faintest of signals even in the presence of stronger adjacent signals. The new ICOM 7610 is a direct sampling software-defined radio that will change the world's definition of an SDR transceiver. It has direct RF sampling, 110 dB RMDR, an independent dual receiver, and dual digiselect. The IC7300 has changed the way entry-level HF is designed. This high-performance, innovative HF transceiver with a compact design will far exceed your expectations. It has RF direct sampling, 15 discrete bandpass filters, a large 4.3-inch color touchscreen, real-time spectrum scope, and an SD memory card slot. Visit icomamerica.com/amateur for more information on ICOM radios. So, Martin has dropped off. He is ready to go to bed. It's getting late over there. Riley has also left us. So now, hey, we've got Pat here, K7 LNP. I kind of like to think of that as low noise preamp myself. That's how I remember it, you know. So, Pat, we're going to get started with a segment for our people that are interested in VHF and above. You know, we really haven't talked about that on the show, and hopefully we can develop something that will bring some interest to them. So let me bring you back into the show here, Pat. There we go. And what do you got for us tonight? What do you want to talk about tonight?
Well, you know, Tom, I was thinking we could kind of, we discussed a lot of different things on the phone as far as different subject areas that we can talk about. And tonight, I'm thinking about maybe just laying a little bit of groundwork down, talk a little bit about cables and relays and connectors and stuff. And as you mentioned, you know, there's a whole world out there as far as weak signal operating goes. Everybody, you know, when you think about an HT or you think about VHF and UHF, so many people think, well, it's my local repeater I can get on, or, you know, on 450 or 220 or, you know, even 1.2. But a lot of people don't realize there's a whole world underneath that There's a lot of sideband activity. There's the digital products have really FT8 has really changed 6 meters. It was a spectacular summer on 6 this year. I worked quite a few new countries, even though the sunspots are not in our favor. It was just an amazing year, and there's so many different things that you can experiment with these weak signal modes. Again, we can run meteor scatter skeds, and we'll do a program on that. And of course, EME is very interesting to just about everybody. I've had the opportunity to do that for many, many years, and I've had pretty good success with it. 6 meters, all forms of propagation are there. Everything from sporadic E to single hop, double hop, F2, backscatter, tropospheric openings, and as of recent, there's more and more 50 megahertz single Yagi EME stations appearing all over the world. So guys are working countries off the moon on 6 meters. So I think for quite a few shows out, and hopefully for a long time, there's a lot of different areas that we can touch base on. But what I'd like to talk about a little bit tonight, and just share a few couple diagrams and some stuff with you to set the precedence for all this. If you're going to delve into this, this world, and you're going to move that direction, the equipment, the feed lines, the antennas, everything has to be a little bit better than just substandard. I know the last couple shows, there's always been some discussions about cabling, RF cable and coax. I'm going to go ahead and I'm going to bring up a little chart here. I'm going to do is share my screen. See if we can do this. Let's see, share the screen. And come on, screen. Yeah. And let's get a picture up. How's that, Tom? Can you see that? Is that pretty decent?
There you go, looking good. Yeah.
Okay. So let's just talk a little bit about coax. If you're going to delve into the 50 meg and above, I would say as far as 6 meters go, I kind of handle things the same way there as I would handle anything I'd put up for HF, because it's close enough. But, you know, we talk about a lot of different cables. We talk about RG58. We talk about 8X. I think RG8X, I think it's an amazing cable. It works great in the shack. It's good for 100, 200, even 300 watt. Actually, I've run up to 500 watts to a dipole on it. It gets a little bit warm, but it does pretty good on HF. But once you start to move above 50 megahertz, if you look at the chart, once you start to get up around 100 meg and then go up from there, the attenuation, the loss, it climbs pretty rapidly. RG8X works pretty good, again, all the way to 50 meg. But if you look down over here at 9913, the Belden 9913 at less than a dB a loss versus 2.5 dB, that's quite a bit. And as we move up to 450, you're losing almost 10 dB with RG8X versus 2.5 dB with 9913 or an LMR 400 equivalent. So I guess what I'm saying is that if you're going to experiment with anything above 50 meg, probably the most important thing is to use good quality coax. Putting up an antenna for EME or for satellite work, anything like that, especially up in the 432 region, RG8X is just not going to cut it. RG58, without a doubt, is not going to cut it at all. 174 is on this chart. It's great for little jumpers and your project boxes. But I would say that to kind of start things off, we want to go through and get as much of the signal to the antenna as possible. Use a good high shielded coax to keep the local noise down, and you'll have success. It's harder to work this stuff up higher, without a doubt. The signals are lower, and again, to generate power up there is a little bit more difficult. So you want to put as much power as you can out of the back of the radio or the amplifier up to the antenna. So just wanted to kind of go over that a little bit. As far as connectors and stuff go, same thing. I'm a big I really like end connectors. They're waterproof to begin with. They can handle a heck of a lot of power. A PL259 or a UHF connector is a great connector. It's good to, I would say again, if you're using it for low power, they're actually rated to 300 megahertz. So for 2 meters, they're fine. You won't find too many 450 radios that have, an SO239 connector on them or a UHF connector. Anything above that, I would stay away from that type of connector. It was interesting. I did a little bit of research on these connectors, and the UHF connector, or the PL259 connectors, everybody knows that it was actually invented back in the 30s. I didn't realize it had been around that long. The end connector was actually developed and invented by Bell Labs back in the 40s. The gentleman that actually invented the connector or designed the connector was a guy by the name of Paul Neal, and he worked for Bell Labs, hence the N is where the N connector came from. The BNC connector was designed for military use by Bell Labs as well, and Mr. Neal was involved with it, and a gentleman by the name of Carl Councilman was involved with it. And the BNC is actually, as we know, it's a bayonet type connector. They're good they was developed for the military. They're good up to 2 gigahertz. And BNC stands for the bayonet Neal Councilman connector. That was kind of interesting. The PNC connector, same type of connector, same 2 gentlemen, Neal and Councilman, except for thread. So again, these were all connectors that were invented in the 40s and 50s, and they've been around for quite some time. So again, the BNCs work really good. The SMA connectors work really good. Again, these are all low loss connectors that can be used, with your different applications. Again, PL259s. And RG8X or RG8 or a 213, an RG213 will work fine on 6. But again, as we move up in spectrum, a better quality cable is needed. The other thing to share a little bit with, if you're going to delve into this part of the hobby, let me get my. Bear with me here a second. Got too many windows open. If you're going to, let's try this. If you're going to start playing with stuff above 220 megahertz and start introducing high power, there are some other cables out there. LMR 600 is a real decent cable. The numbers there on top are the loss, that's the attenuation per 100 feet. Half-inch LDF, of course, is hardline, 7/8 is hardline, 1.25 is hardline, and 5/8 is hardline. It's made by, hardline is typically made by Andrews, although I think ComSpec and a few other ones put it out. More expensive, a little harder to handle, but over the years I've been to a lot of ham fests, been to Hamvention many times. You can always find hardline used, and I never have really been too concerned about buying used hardline as long as there's no kinks in it. I know here in town there's a couple repeater clubs that every few years they change out all the cabling and they offer it pretty doggone cheap. The connectors have come way down in price. There's some out-of-country connectors that have been duplicated. You can get some stuff out of Russia that will fit the hardline. They're all waterproof connectors to begin with. So again, if you're going to move up in frequency, going to move up in power, and really get into this, I would suggest considering looking at a hardline type cable. One thing I would be cautious about, if at my station for 2 and above, actually, I run 7/8. It's all used. I picked it all up used over time. But one thing I would suggest to people, let's see if we can get this up. I don't know if you can see that. This is 7/8 hardline, but this is something called cell line. It doesn't have a foam dielectric. It's got this sent this I don't know what you would call that, but the insulator to hold it off the copper off the copper. Some of this stuff you can find pretty cheap. I learned the lesson. I bought a ton of it and had a lot of issues with it, and I found that I thought I got a really good deal on it. I thought, man, I'm going to change everything out to this, but I found out later on that you actually need to have a piece of equipment that removes the moisture out of it periodically. If it gathers condensation, it really doesn't like that. I actually put a piece up on a 2-meter array, and I was having all kinds of SWR problems. And I later learned down the road that this does not work too well. So I would take a look here. Here's some standard. Here's some standard half-inch heliacs. Very, very well shielded, extremely well shielded. It's got a solid outer core on it, a dielectric and a thick inner core. You can put a ton of power through it, and again, its losses are very negligible at the higher frequencies. So through the years, I've experimented with a lot of different cables, and I've had a lot more success using the better cabling, a lot less noise in the shack, on the radios. Power's never been an issue. It's just worked out well. So I guess without sounding like a broken record, go with the best cable that you can afford if you're going to decide to kind of go this route for whatever application.
Pat, let me show you a cable that I'm using here. That is something I've just recently installed here for VHF and UHF. Mm-hmm. It's probably it's a little bit better than LMR 400, but you can see it's like 100% shielding there. It's very tight shielding. Look at that center conductor. It's stranded, and they've got a lot of extra wires in it. Even the dielectric is some kind of special dielectric. So this is their this is called Hyperflex 10, and it's by Messi. And actually, MFJ is the U.S. distributor for this cable now. This comes from Italy. And if you guys watched our Dayton Hamvention, you probably saw Stefano. He's the man from Italy that hooked us up with this cable and sends it over to Martin. So this is some pretty good cable here. I would say, unless you're going to go with hardline, something, I think something like LMR 400 or this Messi cable is pretty good.
That's nice looking stuff.
Yeah.
That looks really good. And in the chat room, Andy made the comment about that cell wave, and he's correct. It's got to be pressurized with nitrogen gas. Again, I didn't realize that you needed the dryer and the pressurizer, and I had all kinds of problems with it. Ended up just getting rid of it. It was really a pain. But again, that appears to be. I haven't looked at the specs on that. There's so much new product coming out. But it looks like it'll definitely do the job.
All right.
One other thing I'd like to talk a little bit about is and show some pictures. Again, when we talk about getting working stuff up on the higher bands, a preamplifier is a pretty common thing that's going to be needed. Not necessarily for 6 meters. But a good low noise, well-developed preamp is really a necessity on 2 and above. I actually have a preamp up my tower, which is this little guy here. This is a mast-mounted preamp. This is put out by SSB Electronics. It's a gas FET preamp.
Can you transmit? Can you transmit through that, or is it receive only?
No. You cannot. That's okay. What I wanted to bring up. You cannot put any power through that. So what you need to do is you need to incorporate a couple of relays. I will show you what I use here in the shack, or what I use up. I don't want to share my screen. There we go. Share screen. Share screen. What I use in my up my tower. Is one of these guys here. This is an N connector. It's all N based. It's made by RCL. You can find these on the surplus market. This one will run on 13 to 15 volts with no problem. I use a pair of them. So when you are in receive mode, you are bypassing the preamp. When you go into transmit mode, when you're in receive mode, the preamp is in line. When you go into transmit mode, it takes the preamp out of line. I have all my preamps up at the antenna. Reason for that is that I want to be able to raise the signal as high as possible, but keep the noise floor as low as possible. So having the preamp up at the antenna is really the ultimate way to do it. It does throw a few complexities into it. Probably one of the thing that you have to be most careful about is not popping the preamp. If you dump any kind of power into it at all, if you use a very low grade, low quality set of relays, you want something a relay that has that has high isolation at the higher frequencies. Sometimes what I'll even incorporate and show you this is, I do a screen share here again. This is the box that I have up actually for my 2-meter array right now. It uses, there we go. That's it right there. It actually uses 2 relays. In the receive mode, it leaves that LNA technology preamp in line. When you go to transmit, on the left-hand side of the box, you see that other relay there? It's got a little 50 ohm load hanging off of it. It was overkill, but when it was 10 below zero, I didn't want to have to go up the tower and have all kinds of problems. So when you go into transmit mode, when you take it out of receive mode into transmit mode, it actually dumps one side of the preamp into that other relay. It switches it over to that 50 ohm load. This way there's less of a chance, very less of a chance of that preamp getting damaged.
So how are you powering? How are you powering it? You running a 12-volt line up to it?
Yes, I'm running 12 volts up to the box. The relays are 12. All 3 relays are 12 volts. Those are 2 Tohatsu relays, and it's 12 volts. The preamp is 12 volts, and something we can talk about a little bit down the road is I also incorporate a sequencer in line as well. So what that does, Tom, in essence, is when you key the microphone or key the radio, you want to ensure that that preamp is taken out of line. It's only a microsecond delay, but it gets it out of line first, and then you can go ahead and transmit from there.
You know, there is, and I've been looking into this. I may have to do this with my satellite deal since I've got such long runs, but there are some preamps out there that are designed that you can transmit through. Not a power amplifier, but it just switches automatically. I think MFJ's got some, and several other companies are selling them. I think you can transmit up to 160 watts through them without damaging the preamp.
Yeah, Advanced Receiver Research has that. SSB Electronics, they put out their, I think they're called their SP 2000. I think they're actually rated at full legal limit. Very well made stuff, except it comes with a pretty hefty price tag on them. But I like the setup with the two relays up the tower and the third relay incorporated in there to dump it off. Some people, and I don't have a diagram for that, but some guys actually run a 2-line system, especially when we start talking about where you're using your HF radio and a transverter with a separate receive and transmit output on it. In that case, some guys are running actually 1 relay up at the antenna, and then they're running 2 coax lines down, a transmit side and a receive side. Then they don't have to worry about the complication of the preamp taking a hit of any sort because it's sitting on its own coax. But again, now you're doubling everything up, and it depends how you want to do it.
All right. Anything else that we're going to talk about tonight, or
no? Just kind of wanted to. I'm going to do some PowerPoint presentations on some stuff that I've put together, but just wanted to kind of start talking about some things, get people thinking about if you're gonna give this a try and play with it a little bit, to look at the look at using some decent coax. We've got some guys here in the valley that are getting into EME, and they're getting into satellite work and meteor scatter, and trying to help some of them out. And again, one guy just went out and bought a ton of RG8X for his EME array, and it's like, well, I don't think you want to go that route. Go ahead and put something up that's going to be quality and is going to work well, and you're not going to lose half the signal in the cable.
Well, this is a great start on our new segment, 50 megahertz and above, and we'll just keep expanding it each time. More about different aspects of it.
You kind of broke up a little bit, Tom.
Yeah, I said that we will, this is a good start on our 50 megahertz and above.
Oh,
Are you
sounds
hearing?
good.
Yeah.
Sounds good.
And we'll just keep expanding on this on future segments, and we'll just start covering a lot of different parts of this. Pat, thanks so much for sharing that with us tonight. It's getting a little late here. I'm going to go ahead and open Hangout up and see if anybody wants to join us in Hangout. I'm not going to stay very long, but we're going to go to Hangout. Thanks so much, Pat. We'll see you on another show here in the next week or two.
Okay, Tom. Thank you for having me.
All right. Thanks, man.
Take care.
All right. We're going to go to Hangout now. And we'll see who's in Hangout. If somebody will paste the link for Hangout, we'll open Hangout up. This is where you are able to join the show if you've got a camera. All you do is click on the link and you'll be on the show. If you do join us on Hangout, please, on the audio you're listening to right now, the video player, mute it or stop it, because you don't want that on when you're in Hangout, or we'll have two different audio tracks running, and it will cause problems. So here we go with Hangout. Let's see. It says I'm the first there. All you have to do is click on that link right there, and you will be on Hangout with us. Might not have anybody tonight. We'll see. Hey, next week we're gonna our show is going to be about some satellite operation, and it's also going to be about a day in the park down at Olive Branch, Mississippi. We've got drone coverage, we've got interviews, we've got a lot of things going on. So please tune in next week and join us for Amateur Radio Roundtable, 8 p.m. every Tuesday night, 8 p.m. And of course, our 40-meter net is at 5:30 to 7 p.m. Central Time. If you're interested in calling a net, send me an email, tom@w5kub.com, or shoot me a message in Facebook, and tell me if you're willing to volunteer and run a net for us. We'd like to start a net on 20 meters and maybe a net on 75 meters to pick up people from different distances. 40 is working out pretty good, but it covers the same area every night. So we'd like to open this up where we can have other people across the country join us. I don't see anybody else to hang out, so I'm thinking that we'll just go ahead and end the show. And we thanks to everybody for joining us tonight, and we will see you next week.
So you're saying I can ask this cat any question?
The cat is connected to the computer. You just type in the question, it will read his mind. There the answer comes.
You're the man! I've been looking for this for weeks.